With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The centers of three spheres 1, 2 and 3 lie on a single straight line. Sphere 1 is moving with an initial speed v1 directed along this line towards sphere 2. Sphere 2 and 3 are initially at rest, acquiring some speed after collision. Sphere 2 hits sphere 3. Sphere 1 and 3 have masses m1 and m3 respectively, and all the collisions are perfectly elastic and head-on. Then, so first of all, the situation is that we had three spheres. There was the sphere A, sphere B, and sphere C. Now, this sphere A had some velocity. It collided with sphere B. Then, due to the collision, this sphere B got some velocity, and this sphere collided with sphere C. So, let's talk about the initial conditions. So, initially, velocity of A is equal to v1. This is given in the question. And the other two spheres were at rest. So, velocity of B is equal to 0 and velocity of C is equal to 0. Next, after the first collision, meaning the collision between A and B. So, after first collision, let's say velocity of A becomes v2 and velocity of B becomes v3, and velocity of C will still remain 0 because the collision involved only A and B. Now, for the first collision, if I write the equation of conservation of momentum, so initially the momentum was m1 into v1, that is mass of A into velocity of A. This should be equal to, next, after collision, the momentum of A will become m1 v2 and momentum of B will become m2 v3. Let's say this is equation number 1. Now in the question it also says that the collisions are elastic in nature. So if the collisions are elastic in nature, I can say that coefficient of restitution is 1, which means 1 will be equal to the velocity of separation, which will be v3 minus v2 upon the velocity of approach, which is v1 minus 0. This is for the collision of A and B. So from here, v1 is equal to v3 minus v2, and if v1 is equal to v3 minus v2, then v2 is equal to v3 minus v1. Let's say this is equation number 2. Now from equation 2, if I put the value in equation number 1, I get m1 v1 is equal to m1 into v3 minus v1 plus m2 into v3. So that means m1 v1 is equal to m1 v3 plus m1 v1 plus m2 v3, which means 2 m1 v1 is equal to m1 plus m2 into v3, which means v3 is equal to m1 plus m2 upon 2 m1 v1 upon m1 plus m2, 2 m1 v1 upon m1 plus m2. So this is the value of v3. Now similarly, if I assume that after the second collision, that is the collision between B and C, the velocities become velocity of A will remain the same because it was not involved in the second collision, so its velocity will remain v2, velocity of B, let's say, becomes V4 and velocity of C becomes V5. So once again, if I apply the principle of conservation of momentum, so for the second collision, the initial momentum of the system will be m1 v2 plus m2 v3 plus m3 into 0, and final momentum of the system will be m1 v2 because the velocity of A remains same plus m2 v4 plus m3 v5. So from here m1 v2 and m1 v2 get cancelled and we get m2 v3 is equal to m2 v4 plus m3 v5, which means v5 will be equal to m2 v3 minus m2 v4 and m3. Let's say this is equation number 3. Now since this collision is also elastic in nature, so coefficient of restitution is 1, which means 1 is equal to the velocity of separation of B and C will be v5 minus v4 and velocity of approach of B and C will be v3 minus 0. So v3. From here v3 is equal to v5 minus v4, and which means v4 is equal to v5 minus v3. This is equation number 4. Now if I put the value of equation 4 into equation 3, I get m3 v5 is equal to m2 v3 minus m2 into v5 minus v3, which means m3 v5 plus m2 v5 is equal to m2 v3 plus m2 v3, which means v5 is equal to 2 m2 v3 upon m2 plus m3. This is equation number 5. Now if I put the value of v3 from, let's say this was equation number 2 second, into equation number 5, I get v5 is equal to 2 m2 upon m2 plus m3 into v3 is 2 m1 v1 upon m1 plus m2. So 2 m1 v1 upon m1 plus m2. I get v5 is equal to 4 m1 m2 v1 upon m2 plus m3 into m1 plus m2. So this is the expression of v5. Now the options say that m3 will acquire maximum speed when m2 is equal to m1 m3, or m3 will acquire maximum speed equal to 4 m1 v1 upon root m1 plus root m3 whole square, which means the options are regarding the speed, the final speed of mass m3, that is the sphere C, and the final speed of mass m3 is v5. So we have to maximize this v5 and we have to find the conditions regarding that. So now in this expression of v5, we have to treat this m2 like a variable. So if we want to find the maximum value of v5, that means we have to find the maxima of this function v5. So we will have to take a first order derivative with respect to m2 and set it to 0. So when we take a first order derivative of this and set it to 0, we get m2 square is equal to m1 m3, which means m2 is equal to root over m1 m3. So the sphere 3 achieves its maximum velocity when the mass m2 of the sphere 2 is root m1 m3. That is option number A. And the maximum velocity that it achieves will be v5 when we have put the value of m2 is equal to root m1 m3. So we put the value of m2 as root m1 m3 into the equation for v5 and we get 4m1 root m1 m2 into v1 upon root m1 m2 plus m3 into root m1 m2 plus m1, which is equal to 4m1 v1 upon m1 m2 plus m1 plus m3 into root m1 m2 plus m1 m3 divided by root over m1 m3, which is equal to 4m1 v1 upon m1, this is m3, this is also m3, so root m1 m3 plus m1 plus m3 plus root over m1 m3, which is equal to 4m1 v1 upon root m1 plus root m3 whole squared. So this is the maximum velocity that the sphere C can achieve, or the sphere of mass m3 can achieve.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.